Hi, everyone. We're getting started, so feel free to take your seats. I'm Christina. I'm the events manager here at Fastly. We're a CDN, Content Delivery Network. Welcome to our space. Ourselves and Internap are a sponsor of this meetup. I don't think Internap is still here in the house, no? Oh, he is? No? Okay. Oh. Well, when you can, if you'd like to come and say a little something.
Hey, sorry about that. Yeah, my name is Steve Munt, and I am a sales rep with Internap, and I want to thank you all for coming out and hopefully enjoy the beer. I heard the keg is non-operational right now. Hopefully we'll get that fixed. But yeah, so Internap is a hosting provider. We have 16 data centers across the country, here domestically as well as in Singapore and Amsterdam. We specialize in high-performance data center solutions. So if anyone has any questions or is interested in taking down some space or bare metal servers, hybrid cloud infrastructure, I'll be around. So enjoy the meetup. Thanks.
And I'll introduce you to Eli Bixby. Go ahead.
Hi. I don't know if we can get this situation. Yes, no. Yes. Okay. Hi, I'm Eli Bixby. I'm a developer programs engineer with Google Cloud Platform. So I'm going to talk today about continuous delivery in Kubernetes. So this is a challenge that we faced on our team and a lot of people on teams across Google and externally have faced. And this is just a little sample of how we dealt with that and also give you a little intro to Kubernetes and what it is and what it's useful for. So first, sort of make sure we get our terms. What is continuous integration? This is a DevOps crowd, so I'm hoping most of you know what this is. But it's sort of this idea of a development flow where you code and you test and you commit and you push and you build in this nice linear thing and you never make mistakes because you're a perfect developer, but we all know it's really more like this. We make mistakes, we cycle back to the coding part, but you know, it improves things. And in case you still need to be convinced, well, I'll get to that later. But continuous delivery is sort of a superset of continuous integration. The idea we take that nice linear pipeline and we put it before a deployment stage and we deploy to a variety of environments, be it testing, staging, or production directly, depending on whether our tests pass, whether manual improvement stages, whatnot. So why continuous? Why not just do it the old way where you ran a testing script and waited for it to complete? Well, in developer programs engineering, we write samples and tutorials and blog posts and third-party integrations for 21 products across 7 languages, which results in 300 plus GitHub repositories that we are responsible for to varying levels. And we have across cloud about 5 releases a week, which we're responsible for. And we do this with 18 developers. So there's no way we could do this without a good continuous integration system. It tells us when a engineering team pushes out a release that breaks all of our sample code. And while it doesn't fix it for us, it gets us part of the way there. So it allows us to fail fast, know when we broke the build, blame fast, know which engineering team broke the build, and that allows us to deliver fast. So there are a lot of tools that people use for CI. You might be familiar with any number of these. A lot of them offer hosted builds, hosted CI. We certainly take advantage of that in some cases. But for some cases, we need an in-house solution, or we need something we're running ourselves, so we can keep our keys to ourselves, so we can configure things to the maximum extent possible. And so for this, we choose Jenkins. However, if you've ever been responsible for babysitting a Jenkins server, you know that there are lots of problems that can happen with a Jenkins server. And so you have to answer these questions. You have to answer, how do you address build isolation? How do you address build scaling? What happens when your Jenkins queue gets clobbered because all of your engineers are drunk and pushing out code like crazy? How do you deal with dependency management? And how do you make sure your server stays up? And if you're providing a software that runs across multiple OSs, how do you have a Jenkins host? Do you have a completely separate server for Windows? How do you deal with that? So I'm going to go back to prehistory and talk about how people used to run their Jenkins servers, which was on one single machine that was living in a data center somewhere, and you had an OS that was running on top of a kernel and libraries, and your app was strongly coupled to that OS, and you just ran everything right there. And clearly there's a lot of problems with that. We don't get any isolation. We don't get any namespacing. All of our binaries share all of our libs. And ultimately, this results in our apps being highly coupled. So what I would say maybe is present, hopefully soon moving to the past, is virtual machines. They offer some isolation, which is nice. You're running a kernel for every app here, which is not necessarily necessary. There are certainly many libraries that would be comfortable using the same kernel, and many applications that would be comfortable using the same libraries. So you get some isolation. It's inefficient. You still end up highly coupled to the guest OS because you're running on a machine that has a specific OS, even if it's virtual. So the new way, which hopefully many of you are using, or if you're not, you can get excited about using them now, is to have all your containers running on top of a shared kernel. And these containers are a set of dependencies and an application that uses those dependencies, and they run side by side. And in this case, the pink box could be a virtual machine. It often is. Sometimes it's bare metal. So I didn't really tell you what they are. I just told you what they do. So they share an operating system kernel. They are stateless and contain all dependencies. Some implementations use a layered file system, probably the most common Docker does. And they allow you to sort of encapsulate all the dependencies of your application. They provide isolation in the network space, in the file system space, in the user space, and they allow you to sort of allocate a discrete amount of resources. So there's a lot of reasons I've given. Performance, repeatability, like I said, it's this defined set of dependencies. They offer even more isolation over virtual machines. And this allows you to deliver a higher quality of service, to have your apps be more accountable to the system that they're running on, and gives you, more visibility into which apps are doing what, and allows you to port apps across a wider variety of platforms. So containers are great. That's all I'm going to talk about them. You should check them out if you haven't already. But unfortunately, now that we have containers, we have a lot of problems that we have to answer. How do we keep containers from interfering with each other? How do we decide where to run containers, since they often go down? Sometimes we want to spin new ones up. How do we keep them running? Where are they running? If I'm spinning them up and spinning them down dynamically, I need to know where they're ending up. And then which containers are responsible for ending up serving which app? So if you have an app that's factored into a backend and a front end, how do you know which containers are running any particular app, serving any particular request? How do we do auto-scaling? Authentication, monitoring, health, these are all sort of obvious questions. And the answer to all of them is Kubernetes. So what is Kubernetes? It is a container orchestrator. What does that mean? We'll get to that, but it is, the name is not just nonsense like consonant vowel that we strung together. It means helmsman in Greek, and it's was meant to convey governorship of containers. So Kubernetes runs your containers, and it supports many different cloud environments and also bare metal. So AWS, GCP. Most importantly, it's open source. So we really want this to be a project that the community is responsible for and takes on a life of its own. We've given it to a foundation to ensure that. But we also want to make sure that Google's extensive experience running containers is part of the lifeblood of Kubernetes. So Google starts up about 2 billion containers a day. We've been using them for over a decade. We've done this at scale, and we want to make sure that everyone else is able to do it at scale too. And the end goal of Kubernetes is basically, how do we manage applications rather than managing machines? Because even though we do DevOps, we would like our job to go away, right? We would like to be able to sit and play Tetris all day. Or maybe not, but at least like to write applications without having to worry about the machines they're running on. So what are the sort of primary concepts of Kubernetes? There's the idea of a node, which is the hosts that your containers are running on. So these could be Google Compute Engine VMs, they could be AWS VMs, they could be bare metal if you wanted. There's the idea of a container. We've already covered this. Docker is by far the most common. We do plan on making sure Kubernetes supports a wide variety of container formats. And the pod is sort of the atomic unit of scheduling for Kubernetes. So if you have a group of containers that you want to make sure are always brought up and brought down together, you co-locate these in a pod, and this is the object that Kubernetes addresses when it's scheduling. So you don't talk about single containers, you talk about pods, which are groups of containers that operate together. Think like a pod of dolphins. Controller is sort of the other Kubernetes concept that's going to be widely expanded. Basically, the idea is that Kubernetes is declarative rather than imperative. So you say what state you would like your cluster to be in rather than saying what you would like your cluster to do, and Kubernetes takes care of moving your cluster towards that state. So a controller is just a loop that drives current state towards desired state, and one example of that is a replication controller, which tries to make sure a certain number of replicas of any given pod are started up or are running. A service addresses sort of constituency, which pods are part of which service. It's more or less a set of pods that are addressable together. Most services offer a static IP for your pods, whether it be external within the cluster or external, or they open a port up on the cluster. So an example of that is a load balanced backend. So you have a set of pods that are running that are addressable by a static IP in your cluster and invisible out from outside your cluster. So labels are the universal metadata of Kubernetes. So a label is just a key value pair, and you can assign it however you like to any object in Kubernetes. And that brings us to selectors, which is basically how groups are formed in Kubernetes. So you don't explicitly declare group membership. You rather give objects a set of labels, and then you can have selectors, which query a set of labels that form a group. So for an example, a replication controller isn't a defined set of pods. You give it a label, and it drives pods with those labels towards a certain number of replicas. So I'm going to start the demo portion now. If you would like to follow along, you can. These are the repos. What we're going to do is start up a Kubernetes cluster. So start up a Kubernetes cluster. Start up a Kubernetes cluster. OK. So I've already done this because it takes a little while. This is Container Engine. So this is Google's hosted Kubernetes clusters. We host the Kubernetes master for you, and we also deal with a lot of the initial configuration. So while we want Kubernetes to run everywhere, we would like to be the easiest place to run Kubernetes, and this is our attempt at that. So you'll see we have 3 VMs here, various statistics about them. And what we're going to do is we're going to create a Jenkins server, and we're going to give it a service that addresses that server and makes it accessible to things that are internal to the cluster. So we created a service and a replication controller. If you want to see that config, it looks like this. Kubernetes configurations are defined in YAML format. They're pretty simple, despite what this looks like. So you see we've given the replication controller some labels. We've also given some labels to the pod that the replication controllers create. Here's the number of replicas. We only want one. We don't want to confuse multiple Jenkins servers on our cluster. a pod is a list of containers. In this case, we only have one. And if you're familiar with Jenkins, you know that the web UI comes in at 8080, and slaves have to register at port 50,000. And so we've opened those two ports up to the cluster. And we can also define a service in the same file. You'll see this service targets the ports that we defined up here. And a service has a selector object, and you see that we select the labels that we gave our initial Jenkins server. So we can actually, you can see there's a pod running. If we want to get more detailed information. You can see sort of a log of it starting up. You can see it pulls down the container that we're using to run Jenkins, starts it up, and there's nice things like state, how many times it's been restarted because it's gone down for no reason. So as I said, our Jenkins service isn't actually accessible from outside the cluster yet. And this is for good reason. We actually don't want to expose the 50,000 port to the open internet, right? We don't want anyone to be able to register a build agent on our Jenkins server and then grab a build config and maybe get our private code. So what we're going to do is we're going to put an Nginx reverse proxy in front. And this is a very similar thing. We configured a replication controller that just has one replica and a service that lives in front of it. Services come in 3 different types: node IP, or node port, cluster IP, and external load balancer. And so the service we created before was a cluster IP. It provided a static IP to processes running within the cluster, and it isn't accessible from the external web. So this one is an external load balancer. Cloud providers can plug into this to actually create load balancers that live in front of your Kubernetes cluster. This provides an external IP. And if we look here, oh, that's the wrong one. If we look here, we'll see it's creating a load balancer, and hopefully, if we go to this IP, we'll actually see our Jenkins server. It's a password. Great. So here's our Jenkins server. Okay, so far we've ran a Jenkins server. That's not very impressive. Doesn't really help us at all, except that Jenkins server comes up if it goes down. That's kind of nice. But what we really want is something like this. We want a bunch of builders that are completely isolated from each other and scale with the amount of load. So here we're going to do all right, so what we've done here is create a replication controller. We didn't create a service with this one. We don't need an IP to address these. They're going to talk directly to the Jenkins service. So you'll see we have one current, one desired, sort of the expected state and the current state, and we have one running. Great. And if we go over to our Jenkins cluster, we see, yes, indeed, that agent has registered with Jenkins. What's actually happening in the container that we're creating is we're running the Swarm client, if you're familiar with it, and we're using DNS entries that Kubernetes provides for services to find the Jenkins service itself. So we have one builder that's not much help to us. Let's scale it up. the time I'm done typing this command, yeah, they're all going to be ready, of course. So here, yeah, great. We've got 5 slaves now. Fantastic. All right, so this slide now accurately represents our cluster state. We have an externally available Nginx reverse proxy that is points to our Jenkins service, and that points to our Jenkins leader, and our Jenkins builders talk to Jenkins through our Jenkins service, which provides a static cluster IP. Cool. So we would like, ideally, to have a nice workflow when using this cluster that we've created. And we're not necessarily going to do that if we go through the sort of the traditional freestyle job configuration of Jenkins. And the Jenkins folks have actually put out a really great plugin recently called the Workflow plugin. And basically what it allows you to do is describe your entire workflow in a Groovy script. And the great thing about that is, just like Travis, if you're used to, you can check in this script to your repo, and Jenkins will watch it and use it to determine what your job configuration is. So I've gone ahead and done that already. So here we have a nice little demo app. All this does is print out the metadata of the compute engine VM that you're running on. So it has 2 different flavors. It has a backend flavor and a front-end flavor. The front-end flavor provides a nice little HTML page that you can view this information in, and the backend flavor just returns JSON. And we do this so that we can sort of mock deploying a microservice architecture to our Kubernetes cluster through this Jenkins. So you can see here, this sort of returns the nice little HTML object. The Jenkins file is a complete description of what we want our process to do. So this tells it we want to run on a Docker node. In Jenkins, we've given our build agents a label, Docker, and so this restricts it to running on our build agents. We can run our Go tests inside a Go container. We can build. Here we're actually building a Docker image in the build agent that is in fact Docker. So our build agent has mounted the Docker directories that are necessary and is talking to the host Docker runtime and is using that to build a Docker image as part of our tests. So that's pretty neat. And once we're satisfied that the tests have run and we've built the image, we can actually deploy this to a QA cluster. So how do we make sure that our Jenkins service doesn't interfere with this QA cluster or with the production cluster that we want to run eventually? Well, Kubernetes provides a really nice feature called namespaces, and I'll show you what I've been hiding under the covers this whole time. You'll see, oh, wow, okay, we already have pods running in a staging namespace, and similarly in a production namespace. Great, and we have a backend and a front-end pod, as we expected. And what we're going to do is try to update these pods in real time when we push to our GitHub repository. So first, I'm going to make sure that we have a job that is watching this GitHub repository. So this is a workflow step style job. So all it does is it watches a repository for a file just like this. Oh no. Yeah, I did it. Okay. So what happens when a stop share button is right next to the clone repository button? Okay, there we go. All right, so right now it's indexing our branches. Hopefully it'll tell us that it found a Jenkins file which defines a job. And in fact, we do get a nice success. Huzzah. Okay. So Now I'm going to pretend that I'm developing on this mock app. And I'm going to change something. What am I going to change? I'm just going to change a color. Great. So the top card in our little UI thing is orange. I'm going to make it blue. And first, I want to make sure it builds initially. So let's build it now before I push. So there's a job for each branch, actually. So, oh, it is already building. Great. So this is the initial build. If we go in the log, we can see all the things it's doing. Great. It has already managed to deploy in a rolling update. So Kubernetes offers a rolling update feature, which basically allows you to have a version of a pod in a replication controller. So a replication controller has a certain number of replicas. It says, rolling update this replication controller to this new version. And the replication controller says, OK, one at a time, I'm going to spin down these pods of this old version and spin up a pod of the new version, which is great. So we see this is the kube control command. So it says namespace staging. Let's do a rolling update of my GCE backend pod. And let's update the image to this particular image. And in just a second, it's going to ask me to look at the staging cluster, or the staging namespace in this cluster, and verify that it looks good. So let's go look. OK, so the top one is orange. Great. I'm satisfied with that. Let's deploy it to production. OK, so we have this deployed to production. It'll get there eventually. I trust it. We don't even have to wait. We can just push now. And this will kick off a new job. Or it won't, and we'll build now because we're impatient. So in this workflow, we have a staging microservice and a production microservice, and we have a repo. And so we have done this first step. We have pushed. Right now, Jenkins is building, and it does this by cloning and deploying to the staging area. So it'll soon ask us it's still on running the Go tests. This is good. We like that our tests get run. We like that they're run because we're running in a completely different worker from our first. We don't actually have to wait. We can run things simultaneously. And because they're in completely different environments, we can be sure that they won't step on each other's toes. So that's great. So 2 successfully deployed to production. That's good. Let's see if this one is asking us for. All right, so we're rolling update to the staging part of our cluster right now. There's only one replica, so it should be relatively quick. Now's a good time if you guys want to ask me any short questions. I think we can probably squeeze those in before this asks me to look at a IP address. Any question? Oh, I lied. Sorry. 1 second. Huzzah! The top one is blue. Okay, I'm happy with this. I'm indecisive. I really want to go back to blue. So I'm going to deploy it back to blue. And this is the final stage. I have approved. I have deployed. I'm happy. This is normally the part where Allan would come up. He's not here. He's not feeling well. I apologize. I, however, can talk a little bit about what is new in Kubernetes for you Kubernetes power users in 1.1. So one is basic improvements to performance and scalability. Sort of the supported cluster size was 100 in 1.0. We're hoping to up it to 250 in v1.1. There are people running clusters up to 1,000. Supported basically means it's within our declared performance constraints. Cluster autoscaling has arrived. It's super exciting. You can actually attach a horizontal pod autoscaler to a replication controller, and that allows you to adjust according to CPU load and in beta sort of custom scaling metrics that you defined. So those are also principal Kubernetes objects now. Jobs, so if you have containers that instead of exposing a service run to completion, you can specify a job, which is a set of pods that will run to completion successfully a certain number of times. So this is useful for your batch processing. People are looking at implementing Spark runners and so forth on top of Kubernetes using this. Really cool presentation from the Pachyderm folks at KubeCon involving jobs. Privileged containers, useful for many things where you need access to the underlying OS are coming. Graceful termination. Allan probably knows more about that than I do. I don't really know what that's supposed to mean. Hopefully things aren't too ungraceful right now. Downward API, so you can reference environment variables that will exist in your container when you declare a pod. That's kind of cool. Simpler deployments, I don't know what that means. I know in the pipeline we have deployment manager is coming along. It's a service that's intended to be a cluster add-on that runs in Kubernetes and expands configurations for you. So you might write a configuration that completely describes the state of a cluster you want, and in a single command you could spin up maybe 4 of those clusters. And this is sort of a prerequisite to the direction things are moving in, which is cluster federation is the term that we're using to describe. Some people have coined the term Ubernetes, which I think is funny, but maybe a little confusing. The idea that you would have many clusters that run across potentially many cloud providers and bare metal even, and that you could address these as a group without really needing to worry about where the clusters are running. So if you're worried about not being able to keep things on premise for security reasons or legal reasons or whatever, watch this space. It's the cliche thing to say there. L7 load balancing has arrived for Compute Engine. That's pretty exciting. More volumes, a private Docker registry that comes with your Kubernetes cluster. Lots and lots of good stuff here. So sort of the roadmap. We open sourced this in June of 2014, V1 in 2015, V1.1 November from 1.0 in July. So that was a big jump. As I mentioned before, Container Engine provides sort of hosted. You don't have to worry about setting up a Kubernetes cluster. We will host it for you and make sure that your config lives up to best practices. So we've already, about a week after the 1.1 release, we had all the clusters in GKE migrated to 1.1, or not migrated, all the new clusters in GKE are running in 1.1 now. So you have access to horizontal pod auto scaling and all those cool features I was talking about. There are lots and lots of partners that are building on top of Kubernetes. Too many to mention in this slide. A few are Red Hat, OpenShift, Dace, Stratos. Too many to mention. There are lots of distributions of OSs that are supporting Kubernetes out of the box. And we're driving towards a 1.2 release in order weeks. So we'd really like to have, for a minor version, we'd like to have a cadence of 3 or 4 months. So we're hoping to accelerate development, and we're hoping the community will help with that. So overall takeaway, containers are a new way of working. They require you to sort of adapt how your app is written. And we think that this is important and good because we think fundamentally the way apps are written is not correct for the cloud. And this allows you to embrace best practices and really benefit from them. As I said, we have a lot of experience with this, but we also really want to make sure this isn't just useful for Googlers. This isn't just a port of what we run internally. And part of that is embracing the open source aspect of this. And open source people care a lot about workload portability, and so we're really focusing on that in the coming months. All right, I'd like to thank Bill Prin, who's here, worked on this. Sandeep Parikh gave this talk, or a version of it, at KubeCon, and Evan Brown also worked on the implementation of this. So, thanks. Yeah, if you guys have questions, I saw hands go up. Yeah.
How do you think the auto-scaling, horizontal auto-scaling will come out? Is that in jobs?
So, yeah, the question was, when will horizontal pod auto-scaling come out, and what about jobs? They are out now with the V1 Beta 1 API. So it's a little bit of work to enable that in GKE, or Container Engine. But Container Engine is in fact running 1.1, which supports both the jobs and the horizontal pod auto-scaling resources. No, it is in Kubernetes. The Kubernetes 1.1 release has been cut. So actually, Container Engine is generally a little behind Kubernetes because we are actually running the open source release. There's no special magic behind Container Engine. It's just that our network engineers know how to run Kubernetes most effectively on top of Compute Engine. So Kubernetes actually runs on top of Compute Engine. So if I go look at this, these are actually just Compute Engine VMs, and all it is it's a managed instance group. So you can go look, for those of you who are familiar with Google Cloud Platform, we just created a managed instance group. There are some VMs here. You can SSH into them. They're just normal GCP. So yeah. GKE is generally a little bit behind, but this time we were only behind by 1 week, which we're super happy about. KubeCon was a week and a half ago, and that was the V1.1 release, which had horizontal auto-scaling. And there's a video of Brendan Burns, one of the core contributors, actually did a video of scaling a Kubernetes cluster to 1 million requests per second with a horizontal pod autoscaler, and kept it within internal cluster traffic, kept it within a 5 millisecond latency time while doing that. So it was pretty cool to see. Other questions?
Hi, thank you. Can you tell me what happens to the state on the Jenkins boxes, the job history and such?
Mm-hmm. So the workflow plugin actually has a really cool way of resumable state. So it's using a continuation passing style call. So you can actually get resumable state from the workflow scripts that you write. That state is passed back to the service, I believe. This may be tricky to configure, but I know there's a way to get the state from the job. Yes, that's not something we've looked into in detail, but I know it's possible. Particularly the workflow plugin supports that nicely. So it's just a matter of making sure it works on top of Kubernetes. Any other questions? Sure.
You talked about the scheduling in the coming releases.
Uh-huh.
Can you give more details? Is it based on number of resources, and what kind of resources scheduling it's doing?
No.
Okay.
Yeah, so right now there is a support for resource limits and resource requirements. So you can define in a pod definition, it should have at most this much CPU and memory, and at least this much CPU and memory. There's also support, I believe in 1.1, if not in 1.1, in 1.2, for defining custom resources. So for example, if you're running a bare metal server and you want GPUs on some of your machines, you could say, this container needs access to 1 GPU, or this container needs access to 2 GPUs, or don't schedule this pod on a node with a GPU because it doesn't need one. That, as far as I know, is as intelligent as the scheduler gets. Certainly scheduling ++, that little entry, hopefully it gets more intelligent, and definitely we're driving towards that. I don't know specifically in what ways. Yeah.
Yeah, would you talk a little bit more about the outward API? So those environment variables that get exposed, those are just those metadata you defined earlier in the pod
Yeah, so I don't believe they will get restarted if your environment variables change. It happens at pod startup time unless something has changed since I last used the downward API. So for example, you could define though, you could say, look at this environment variable to get a queue for what the label on this pod should be at startup. And that's environment variables off of the host.
You mentioned that it's supported in multiple clouds. Can you give some examples of that?
Yeah.
And then
So
the follow-up on that to that, actually, for new service providers like cloud provider, how does it work? Is it just like taking the open source and deploying it, or do you have like a certification support type of program?
yeah, so we have a pretty active community. It is like you have to take the open source release and deploy it. Hopefully, it's you don't have to carve your own way entirely. You can probably, given whatever cloud provider, you can probably find someone who's written a tutorial, and if not, you should write it and contribute it to the repository. As far as cross-cloud providers, what I mean by that is that you should be able to run a cluster in any cloud provider. Not necessarily a single cluster should be across cloud. I think that's something that Cluster Federation is more meant to address, and I don't think we'll be looking to include cross-cloud support within a cluster. Yeah.
Could you describe a little bit about Kubernetes support of persistent storage for containers?
Yeah, absolutely. So we have a concept of a volume, and a volume can take on a number of forms. So it could simply be a mount of the host file system, but additionally, many cloud providers, AWS, GCE, there's talk of adding sort of a image volume. So you would actually pull down an image and use that container to populate the volumes of your pod. Basically, there's this pluggable concept of a volume, and we mount those volumes just like Docker. We mount those volumes at a certain location on the file system of the image. And so compute engine persistent disks, for example, when you mount a volume on a pod, the Kubernetes host, in this case container engine, will know to actually mount that persistent disk on the node that that pod is scheduled on. And then that pod will mount that persistent disk as a volume on the container that says it needs it.
Is that sort of similar to Docker's storage-only containers?
So storage-only containers that would be the sort of the container volumes, which support doesn't currently exist, but there's an issue with design discussion, some of the Kubernetes core contributors that are looking into adding that. If that's all the questions, thanks for having me and listening patiently. Can come up and say hi.
Thank you, Eli. Thank you, everyone, for spending your evening with us, and James and team for bringing the DevOps meeting here. Just a heads up that we're hiring, Fastly is, and if you guys have any questions, we have some Fastly folks here. So please do approach us. Have a good night.